Today's lesson will involve a compass and a straight edge, so if you didn't grab one of those after your quiz, then you need to go back and do that now or get them out if they're in your book bag. So we're hoping that by doing these constructions, you will have a better understanding of what a median is, what an altitude is, and what a perpendicular bisector is, which you've already done. In the next class, we're going to do something with those perpendicular bisectors and those altitudes and angle bisectors, and we're going to see that they all make special points. So right now we just need to learn the basics. How do you construct a median? How do you construct an altitude? And let's review how to construct a perpendicular bisector. So here, construct the perpendicular bisector of the given segment. So remember, what do? You put your compass on the end point of the segment, and then you make your little swoop-de-swoop. And then I go to the other side, the other end point, I make my swoop-de-swoop. And then you line up your ruler, and you're going to make sure that you are taking your ruler and you're going through that point of intersection. I think my pen is a little too wide. And then I line it up like this. Oops, clearly I don't have a good ruler. I line it up, and now I know that this is the perpendicular bisector. What does that mean? It means it intersects this segment and it splits it into two congruent pieces. So this piece is congruent to this piece. And it also means perpendicular, that it intersects this segment, that was the original segment, at a 90-degree angle. So it's the perpendicular bisector. So that was just given a segment, make the perpendicular bisector. So in other words, though, one other special detail is that this green point right here is the midpoint. So if I made the perpendicular bisector, I went through the midpoint on that original segment. Okay, so let's try the second one. The second one says construct a perpendicular to the given line passing through this given point. So we've done this before, but let's go ahead and review it. So the first thing we have to do is take our compass tip and put it on the given point. And then remember, we scoop down here so that it intersects the line, the given line segment or given line, in two places. So now we know these two places are equally distant. If you connected them, we would make an isosceles triangle right here. So in other words, though, we've created a segment right here. And so now if you think of that as a segment, we can just make our swoop-de-swoops down here, our arcs. And then we can line up our ruler, line it up with this point, line it up with this point down here. So these are my 2 points I'm going to line up. Right, so grab your ruler. It's hard for me to line it up perfectly with my ruler, but I'll try. Oops, see, I'm a little off. Still a little off. So anyway, you should have better luck with your ruler. So this is just a perpendicular, right? It's a perpendicular through a point not on the line. So is it bisecting this segment? No, it's not. It's just meeting it at a 90-degree angle, perpendicularly. Okay, so now let's move on to some words and definitions we haven't heard before. So this next example, it says a median of a triangle is a segment from the vertex to the midpoint of the opposite side. So it's a segment from a vertex to the midpoint of the opposite side. So I want you to construct the median for each triangle from vertex A. So I have to construct a median from this vertex to the midpoint of the opposite side. Remember, opposites, this is the angle I'm talking about, or the vertex I'm talking about. This right here is its opposite side. So now I need to find the midpoint of that opposite side, but you're not allowed to use your ruler. You have to construct the midpoint. So recall what we just did. The midpoint is found by constructing the perpendicular bisector. So I'm going to go over here. I'm going to put my compass tip on the edge of this, on the edge of this end segment, right? The end point of the segment, and I'm going to open my compass up more than halfway, and I'm going to make my little swoops above and below the line. And then I'm going to take it back to the other end point of the side of the triangle. And I'm going to make my little swoops above and below. But now instead of making a line that goes through here to make your perpendicular line, right? I could make my perpendicular line, but I don't really need the perpendicular line. I really just need to identify the fact that this right here is the midpoint. Why? Because I just did a perpendicular bisector. So that's my midpoint. Okay, that's not my median. My median, we just said, goes from is a segment from the vertex, so from A, to the midpoint of the opposite side. So my median goes from A to this midpoint. So this right here is a median. Okay, let's try it again. So what do you do to get a median? First step, find the midpoint. Well, how do you find the midpoint? You have to do the perpendicular bisector. How do you do the perpendicular bisector? You go ahead and put your compass on the end points and make your little swoopty swoops or your arcs. So now I line up my ruler. I see right here, this is going to be my midpoint. So my final step is to go from the vertex A to my midpoint, and this right here is a median. Okay, again, I'm a little off because my board, it's hard for me to line up my ruler, but you should be a little more accurate, I hope, on your paper. So if you need more practice with your medians, then make a median from here to this side. So you do the perpendicular bisector of this side, then you connect it. Or do the perpendicular bisector to find the midpoint and then connect. Right? So you can eyeball it. You can get an idea. This looks like the midpoint to me, but you'd have to construct it in order to actually see if it is the midpoint. You have to construct the perpendicular bisector. Okay, moving on to altitudes. Your altitude, so I'm going to erase some of this stuff here. Your altitude, well, what's that definition? The altitude of a triangle is the perpendicular segment from the vertex to the line that contains the opposite side. It's the perpendicular segment from the vertex to the line that contains the opposite side. We're going to start with this one over here, the acute triangle, because it's a little bit easier to see. So your altitude needs to go from this vertex, and it needs to intersect the opposite side at a 90-degree angle. So would that be here? No, that's clearly not 90 degrees. So it looks like it's going to be somewhere around there, right? It has to intersect 90 degrees, but I have to construct that. Okay, so how do I construct that? Well, hopefully you can see this is my point, this is my line segment, and that basically is this construction right here. Remember, here was my point, here was my segment. I had to do a 90-degree angle or perpendicular going from this point, intersecting this line segment right here. It's the same thing with an altitude. We're going from this point and we're intersecting this segment right here. So remember, the first thing we do is we take our compass, we put it on the end point here, and we have to open our compass so that when we do the swoop-de-swoop, it intersects that base or that line segment, right, in two places. So here's your one place and here's one place. So now I move my compass point, I make a perpendicular bisector basically. So I make a perpendicular bisector. I'm just going to do my little swoop here. I go to the other intersection point. Try not to make too much of a mess. I do my swoop here, and then I'm going to connect this point with this point here. So my altitude, I'm going to line up my ruler with those 2 points. I wish you could see me lining it up, but it doesn't really matter. So I line it up. It's a little off, I can see. And really, I'm just looking at this right here. This is my altitude. Right? I could have kept going, which is fine, But that is my altitude right there, from the vertex of the triangle to the opposite side, and it needs to intersect at 90 degrees. So now, let's look at our obtuse triangle. What is tricky about our obtuse triangle? Well, if we try to draw an altitude anywhere inside the obtuse triangle, are any of these angles going to be 90 degrees? Hopefully you're saying no. So the first thing you have to do with your obtuse triangle is line up your ruler along this bottom side right here. And then you need to extend your line. So you need to extend that side, and again my ruler's a little off, but I need to extend that side so that I can have something, because basically my altitude is going to come straight down and intersect at 90 degrees. So I have to extend the side of the obtuse triangle. So now I'm back to square one. Here's my A. I'm going to put my compass tip on that letter A, and now I'm just going to intersect my extended line in two places. I put my compass here and here. I do another point of intersection. So I need to do that again. So there I have to line up now this point of intersection with my A, and then I just connect. Oops, so there we go. So this right here is actually my altitude. Okay, so this here is my altitude. It's on the outside of the obtuse triangle. Now, will that always happen for an obtuse triangle? No, it won't. Hopefully you can see here, if I wanted to do an altitude from here to the side opposite, well, it's going to be on the inside, right? If I want to do the angle from here, the altitude from this vertex to the side opposite, that would be on the outside. We would have to extend it this direction, and it's going to be somewhere around here, because you do your swoop. So practice your altitudes. Maybe one is not enough. You need to practice maybe all of them, right? So you can figure that out. We're going to do some more of those next class. Okay, finally, we're going to try to prove this perpendicular bisector biconditional. So the perpendicular bisector biconditional 4, 5, and 4, 6, it says a point lies on the perpendicular bisector of a segment if and only if the point is equidistant from the end points of the segment. So let's try to prove this theorem. We're only going to prove, if a point lies on the line on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if a point lies on the line, then it's going to be equidistant. So then we should be able to prove that AB equals AC. So hopefully you know by now. You might want to pause and try this on your own. Actually, I think you should do that. Try to practice this proof, and then you can unpause and see how I did it. Okay, I have a minute and a half to explain this. So first of all, we know line L is the perpendicular bisector of segment BC. So that tells me the definition of perpendicular bisector allows me to say that BX is congruent to CX. Then you know that AX is congruent to itself, right? So we have a side here, we have a side here. So here's my second part. And obviously perpendicular bisector means it's going to intersect this line at a 90-degree angle. So therefore AXC should be congruent to AXB. Now why is that? This is the thing that was tricky, was what is that reason? So look up this reason. Remember perpendicular if and only if congruent theorem. So it says that the perpendicular lines intersect at two congruent angles. Therefore I can conclude these two angles are congruent. So that's an SAS situation here. So now I know that this angle is congruent to this angle, which allows me to say that triangle ABX is congruent to triangle ACX, right? Follow the colors. And therefore, we can conclude that AB equals BC, or AB is congruent to BC. That's really what we should conclude, which means AB equals BC. And that's because corresponding parts of congruent triangles are congruent. So go ahead and get out your books and try these questions in your book. Here are the answers. See how it goes. Ask your teacher if you have questions. Ciao.